Actually, we are planning our examination is on 16, 4:30. Hello?
Yes, sir.
Yeah,
Yes, sir.
4:30 to 4:50 it's okay, sir, for 20
4:30,
minutes.
the syllabus is already announced and 20 questions. It's 4:30 to 4:50 it will be ends. Okay, total will be multiple
Okay, sir.
choice only, minor examination.
Yes, sir.
Okay, okay. Then I will start this thing, so my class today. Today we'll discuss about the
Sir,
last
can you
time we
start
finished about the
recording?
catalytic converters. Hello.
Sir, can you start recording?
Okay, I'll stop. And one more thing also, I'm sharing you, your friends. Basically, yesterday's CRC meeting, it is decided that attendance is mandatory for every student. Just now I checked the attendance. The WebEx automatically will be recording. Most of the students joining and going in 1 minute and 2 minutes. Those students little bit cautious because I am taking the Excel sheet of it, and better to stay back in the class and better to attend the classes. Okay, I am requesting you all to make it convenient and attend the classes. Okay, if you have any difficulties, you share with me. Okay, and today onwards, because from the first class onwards, we are recording the system. I have taken the Excel sheet and I have seen the few students just joining and going within a minute, 1 minute or 2 minutes are there. And the time is also mentioning how much time you are spent in the class and all. WebEx will be giving a lot of data. I am also not knowing. Just now I have taken the help of Gangadharudu and I have seen the total Excel sheet of your attendance. Okay. Please kindly cooperate with me and support for the attending the classes. Okay. This method of catalytic converters preheating including the following: by locating the converter close to the engine, by having a super installation, by employing the electric preheating, by using the flame heating, incorporating the thermal batteries. Basically, the catalytic converters, two-way and three-way catalytic converters we have discussed and we have seen the design, and all catalytic converter will help you to reduce the emissions of NOx and SOx emissions by having a chemical equations. Okay, photochemical reactions also will be avoided by using of this little bit. The most effective way, this is basically this is another way how we are going to use it, exhaust gases. This is called easier method, exhaust gas recirculation method. The most effective way of reducing the NOx emissions is hold combustion chamber temperatures down. Basically, around the combustion chamber, we have a heating will be cooling will be there, like a cooling hot combustion chamber. Around the combustion chamber we have a cooling pipes will be there, cooling system will be there. That's why always we have to maintain the combustion temperature inside will be the same temperature. The range should not be exceeding more than. If you exceed it, you will get pre-ignition, a lot of problems. You have seen it while discussing about the combustion chambers, particularly in this NOx and SOx emissions, because of high carbon monoxide and hydrocarbons will be coming out from the exhaust wall to the silencer through silencer. In the silencer end only we are going to have the thing. And before going to the charge, will be heating it through the exhaust gases. What happens if you preheat the air or preheat the homogeneous mixture? What happens? That we will discuss it today. Probably the simplest and practical method of reducing maximum flame temperature is to dilute the air fuel mixture with a non-reacting parasitic gas. And the gas absorbs energy during the combustion without contributing any energy input. The net result is a lower flame temperature. Any non-reacting gas would work as a diluent. Basically, whatever the exhaust gases will come, that exhaust gases will be already discussed, and carbon monoxide will be there, NOx is there, SOx is there, and soot is there, and temperature is there. And this will be having some non-reacting parasite gas type. And if you re-exchange it like a boiler, the boiler, what happens? Almost hot gases will be around the tubes, and inside the tube cold water will be passing, and due to this heat exchange, 100 degrees is sufficient to form the water into the vapor stage as a steam stage. The steam only we are going to use it. The similar way, whatever the air is going inside the engine, that air or mixture will be preheated through sending of this. You know the supercharger, you have seen it, supercharger you have seen it, and we have a turbocharger, you have seen it, and we are going to see this exhaust gas recirculation. This exhaust gases also will be going out freely, which will have giving harm to the persons, and that gases also will be reused it through this exhaust gas recirculation method. We are going to get some preheating will be takes place before going to the combustion chamber inside the engine. The one non-reacting gas that is available to use in a engine is exhaust gas. The one non-reacting gas that is available to use in engine is exhaust gas. And this is used in all modern automobile and other medium size and large size engines. Those engines having a very high capacity, high speeds, exhaust gas recirculation method will be using. Easier setup will be added to this engine and we are going to use it. Adding any non-reacting natural gas to the inlet air mixture reduces the flame temperature and NOx generation. Exhaust gas (EG) is one gas that is readily available for a engine use, and that is one thing. Adding any non-reacting natural gas to the inlet air fuel mixture reduces the flame temperature and NOx generations. Exhaust gas is one gas that is readily available for a engine use. Basically, in these two methods will be there. Sometimes the exhaust gases also will be adding to the air and getting of non-reacting parasitic gas type, and that can be also be using mixing of it to sending to the inside. Exhaust gas recycle (EGR) is done during ducting some of the exhaust flow back into the intake system. What I told you is like a supercharger, like a turbocharger, where we are going to have an additional system to the exhaust, and the exhaust will be collected and you will be connected to the inlet manifold, and usually immediately after the throttle, the amount of flow can be high as 30% of the total intake. Easier combines with the exhaust residual left in the inside the cylinder from the previous cycle to effectively reduce the maximum combustion temperature. It also will increase the maximum combustion temperature for getting of the complete burning of the fuel inside the combustion chamber. The exhaust gas recycle is done by ducting some of the exhaust flow back into the intake system. Usually, immediately after the throttle, the amount of flow can be high as 30% of the total intake, or easier combines with the exhaust residual left in the cylinder from the previous cycle to effectively reduce the maximum combustion temperature. That is also one method. Not only does easier reduces the maximum temperature in the combustion chamber, but it also lowers the overall combustion efficiency. Not only does easier reduces the maximum temperature in the combustion chamber, but it also lowers the overall combustion efficiency. Increasing easier results in some cycle partially burns and the extreme total misfires. Misfiring also you can see it. Thus, by using a VGR to reduce the NOx emissions, the costly price is increased. C emissions and lower thermal efficiency must be paid. And these are all the different points will be there if you use the easier and how it will be acting. A problem of unique to CA engines and using easier is the solid carbon soot in the exhaust. The soot can act as an abrasive and breaks down the lubricant and interwear of the piston rings and valve trains results. Basically, we know exhaust gases will be having more carbon monoxide and hydrocarbons. This will be having formation of layer, and soot also will act as abrasive and breaks down the lubricant because lubrication system also will be damages. Whenever it's coming up, it takes the lubrication, and going down, it will cleanse the lubrication. But lubrication also will be affected through its soot formation and layer formation inside the cylinder liner or sleeve. And emissions may be divided into two groups, invisible emissions and visible emissions. On whatever you are seeing in an exhaust gas, particularly in diesel engines, most of the soot formation and they have a smoke type. And the smoke will have a lot of things, and this is visible. And invisible also, NOx and SOx will not be visible to outside, you can see it by naked eye. But it will react with the air and getting up a lot of things. We have a carbon monoxide and we have water vapors, oxides of nitrogen, unburnt hydrocarbons, carbon monoxide, aldehydes are visible emissions. Carbon monoxide, water vapor means where you can have a silencer end, you can see the small water vapors that will be seeing it. Oxides of nitrogen, unburnt hydrocarbons, carbon monoxide, aldehydes are invisible emissions. Smoke and particulates are visible emissions. I told already smoke and particulates where you have a small particles will be coming out, are visible emissions. Out of various individual emissions, carbon dioxide and water vapor are considered harmless compared to other. Carbon monoxide and water vapors may not be danger, but hydrocarbons and oxides of nitrogen, then we have SOx and NOx emissions, and this will be adding to the air outside the atmosphere and getting a lot of damage to the people, irritating nose and bronchitis, and lot of things will be coming wherever you are inhaling the emissions, automatically you will get health hazards will be coming out from your body. Oxides of nitrogen. Internationally, it's an accepted method for measuring oxides of nitrogen in by um, semi luminescence analyzer, where you can have the particle size and nitrogen can be measured. The principle of measurement is based on the chemiluminescence reaction between the ozone and NOx, resulting in the formation of a NO2. That excited NO2 emits light whose intensity is proportional to NO concentration. The light intensity is measured by a photomultiplier tube. The analyzer measures only nitric oxide NO and not NO. Nitric oxide also will be measured by using a measured by a photo multi-layer tube. Analyzer will be there, and from the analyzer you can have the uh, NOx emissions can be measured, NOx particles to be analyzed, and a lot of things will be done. To analyze the oxides of nitrogen, a converter is usually fitted head to reaction chamber to convert all these oxides of nitrogen into nitric oxide. Thereby, light intensity can be taken to be a proportional to the oxides of nitrogen concentration in the sample. And this is called chemically in science method for measuring of oxides of nitrogen. Basically, how we have a multiple multiplayer tube will be there, and you have a subscriber is the reaction tube is there, where you are going to have the sample gas will be uh, taken here, and it goes to like this, and we have NOx and COx converter will be there. Here the converter will put, and where we have a flow meter also will be there to how much flow rate will be there, and O3 generator will be there to find out the oxygen ozone layer of this from this, how the ozone will be affected by using of NOx and SOx emissions, and it is going to a reaction chamber, and where you have a multiplayer tube is there, there you have senses the total information will be given, how much the particles will be coming out from the exhaust, and what type of damage will be coming to the environment. And carbon monoxide also can be measured by using of NDIR method of measuring of the carbon monoxide. Non-disruptive dispersive infrared analyzer NDIR as shown in the figure, and is widely accepted measurement instrument for measuring of CO. And that the NDIR analyzer, the exhaust gases species being measured are used to detect themselves. The method of detection is based on the principles of selective absorption of infrared energy of a particular wavelength and peculiar to the certain gas, which will be absorbed at the gas. And this is the instrument where you are going to use this carbon monoxide measurement by using of non-dispersive infrared analyzer NDR shown in the figure. And the unbound hydrocarbon, this is also very dangerous, and because whatever the unbound hydrocarbons will be available from the combustion chamber, it will be coming out through these exhaust gases, and these unbound hydrocarbons also will lead to a lot of complications. And this also flame ionization detector will be there. Flame ionization detector will be used for measuring the hydrocarbons. This instrument is shown in figure is well established and accepted method of measuring HC. And ionization is a characteristic of HT compound, HC compound. The principle is employed in the FID detector, flame ionization detector, formation of electrically charged particles of ionized carbon atoms from the hydrocarbons in the hydrogen oxygen flame is achieved in the FID analyzer. Current flow in microamperes, we are measuring it, amplified after measurement, is measured in the concentration of hydrocarbons. This is the one of the way to find out the hydrocarbon percentage in the exhaust gases by using of flame ionization detectors. And visible emissions, like we have smoke, a diesel engine can divide into three categories: blue, white, and black. Where sometimes you will get a blue flame, sometimes you will get a white flame, sometimes you will get a black flame. Smoke measurements can be broadly classified into two groups: comparison method and obstruction method. There we have comparison method. Most of ordinances regulating smoke emissions are based on estimation of the density of the smoke as it emerges from the exhaust. Where you have smoke filters also there. From the filters also how much percentage are coming out and what type of density it is having. It also will be measured by using a small filter paper method. And of several available method, of the one of the commonly used method is a Ringelmann chart. The chart shows four shades of gray as well as the pure white and all black section. To overcome the difficulty of reproducing various shades of gray, the intermediate shades are built from the black lines of various wets. The four intermediate charts are printed by the United States Bureau of Mines in a single sheet, like 70 centimeters into 25 centimeter sheet. This may be reproduced as follows. And zero all white, where you have a flame will have all white, where it will census it say 1 0. One black lines will have 1 mm thick at 10 mm apart, leaving white spaces 9 mm square. That is the measurement criteria will be given. Lines 2.3 mm thick, spaces 7.7 mm square. Lines 3.7 mm thick and spaces 6.3 mm square. Lines 5.5 mm thick, space 4.5 mm square. In all 5 will indicate as all black. And this is the indication of equivalence, equivalent to the 20% black, equivalence of 40% black. You can see this strip thickness and how the formation, and this will have equivalence of 60% black and equivalence to the 80% black. This gives in this chart is set up at an eye level in the line, the stack of at such distances 10 mm or more, that the section appears to be different degrees of uniform gray shades. The appearance of the smoke at the top of the stack is matched against one of the shades on the card and reported as a specific Ringelmann number ranging from 0, no smoke, and 5, dense block smoke. And with practice, an observer can estimate smoke density to half a number, and particularly in the serial number 2 and 4 ranges readings below, Ringelmann are subject to consider errors. This is called the Ringelmann charts, we call it as, and this shows the thickness of the sheet to observe the equivalence to the 20% block of the sheets. And we have another method. It is basically divided into a light extinction type of method and continuous filtering type and SWOT filtering type. These are the different ways of measuring the exhaust gases. Smoke, we're having a photoelectric cell will be there, and we have a light source will be there, and the exhaust will be entering it, and photoelectric cell will be absorbs it, and the light source also will use it, the uh, flame density and these things, and indicating the meter will knows the smoke level. And the light extension type of the method is testing the intensity of the light beam and reduced by smoke, which is measured of smoke intensity. Basically, what we are going to have a pollution testing whenever we are taking to your vehicle to the pollution testing center. What they will do, they will connect to the pipe to the exhaust tail pipe, and in different ways they are going to check it. One is the acceleration method. We have given a slow acceleration and check the levels of the pollution. And if you give the higher acceleration, and how the flame will be coming out from the exhaust, and it can be measured in the two ways of it. And where you have a continuously taken the exhaust sample is passed through a tube about 40 centimeters length, which has a light source at one end and photo cell at the other end. By above figure we are showing it. One side you have a photo electric cell is there, another side we have a light source will be there. From this we are going to have the smoke level or smoke density is defined as the rate of electric output from the photo cell. When the sample is passed through this column, the electric output, when clear air is passed through the and Hartridge smoke meter, we call it as the Hartridge smoke. Hartridge is the scientist name who found these smoke density levels from the exhaust pollutions. It is called Hartridge smoke meter. It's the oldest one where you have the and basic one, the starting one, Hartridge smoke units also, because the units also will be measured in the Hartridge smoke units only. It is very commonly used to instrument based on this principle. This is about the Hartridge smoke meter. This is a very initial stage of pollution levels can be checked in, and now we have a very good instrumentations are available for knowing of the pollution levels at various stages. Particularly in this, we have the light source will be there, and arm will be there here in between, and you have the arm control knob will be there, and clean air tube is there to reference it, and clean air is inlet will be there, clean air blower is there, waste smoke of exhaust will be there. When the waste smoke of exhaust will be coming in, and we have warm drain will be there, will be smoke inlet, smoke waste smoke, and a photoelectric cell will be there here to sense it to know the density of the pollutant. And this can be added smoke meter, and this is having a different stages of it, and it will be spreading inside this smoke meter and gives the density in different stages, like initial acceleration and full oxidation. We call it as initial throttle and full throttle opening. Because if you do the acceleration, full throttle opens and full fuel exhaust will be coming out for this higher engine operating conditions. What is the level of the pollutants from the exhaust? And continuous filtering type, in this method, projects is made continuous reading and observing transient conditions and measurement of smoke density achieved by achieved by continuously passing exhaust gas through a moving strip of a filter paper and collecting the particles. I told already initial stage we are going to have the small filter paper will be there, and filter paper will be keeping to the exhaust pipe, and whatever the deposits will be there from deposits also we can measure the deposits density and all. This is a continuous type of paper. Initially we have 90s, 92, 95 times we used to have a paper method to find out the pollution levels of the thing. Later on, we have a pollution equipment has come up with the demand, particularly in the Hartridge smoke meter. It will give a very good results for depends upon your smoke density levels. And we are going to have this soot filtering type, a smoke strained obtained by a filtering is a given quality of exhaust gas through a fuel filter paper is used for the measurement of smoke intensity. This is again we have exhaust will be having, we have a filter tape will be there, a filter paper will be there, and where we are passing of it, and we're going to have a like piston cylinder arrangement here, and it will be automatically slowly the piston will be moving it outside, and because of this also a lot of deposition will be there on the paper, and to getting of the density, smoke density of the levels. And have a noise. Noise is also very important because because if you maybe observed it whenever your silencer has got a problem, you remove the silencer and listen the engine sound. It's very abrupting of your disturbances. It may goes to the radio frequencies, TV frequencies, mobile frequencies, and a lot of disturbance will be coming out to the noise also. And so each and every two-wheeler or four-wheeler will be connected to the silencer. Silencer will kill the sound and absorbs the flame arresters. A lot of things, the NOx and SOx emissions also will be reduced through passing through this different stages of the silencer. The noise is the maximum. Noise is a mixture of various sounds, which is a source of irritation for the listeners. Sound is created by a vibrating object because engine is having a lot of moving parts, and because of the moving part, because of the combustion, because of the piston will be moving from the top dead center to the bottom dead center, lot of vibrations will be coming to the engine, and that vibrations also will give the sound. and these sounds will be, lot of irritation will be coming from the various sources. The vibrations are transmitted to the surrounding air in the form of pressure waves. The frequency and intensity of the pressure waves are within the specified range. They reduce the sanitation of around 15 to 15,000 hertz of the sound will be coming out, and we call it as in decibels, 0 to 120 decibels of intensity of the sound waves will be coming out. If the silencer is not there and silencer is not properly working it, and you get a lot of things. Sound levels meter consisting of microphone, calibrated attenuator, and electronic amplifier and indicator meter, which reads the decibels of as shown in figure, uh, and show octave band frequency analyzer is suitable for obtaining the frequency distribution in the light band frequency region between 20 to 10,000 Hz. The measurement of the noise emitted by a motor vehicle is based on the moving vehicle. Since it is a total noise emitted by a motor vehicle, including gearbox and transmission. Wherever you have a moving parts, because of the friction and all, and because of this, you have a lot of vibration will be coming. You have vibrational noise and combustion noise and moving of the piston noise. A lot of things will be coming out from the engine, and you have a lot of balancing is required. A lot of vibrations will be coming out. All will be having, and this will use a lot of noise. The noise will be coming out through the engine exhaust will be killed by using of the silencer. Then we have, if you want to have the sound measuring instrument and sound leveling meter will be using to measure the, you have an alternator, amplifier, and alternator. You have a weighing network is there, amplifier is there, rectifier is there, indicating meter is there. A lot of things will be evolved to analyze the sound and what type of sound is coming and what type of noise is coming. Because you may be knowing it, different vehicles will use a different sounds. Have a Hero Honda, four-stroke bike will sound will be different, two-stroke bike sound will be different. And if the cubic capacity is more and engine capacity is more, and noise is also more in the olden days. Now we have a lot of system electronics that's coming up, and a lot of instrumentation is used, ECU method, and controlling of the combustion phenomena, and we have the noise and exhaust also. Now we'll go to the, these are the measurements and all. Now we'll go to the emissions. What are the emissions? How the emissions will be decided and who is going to decide the emissions? Basically, in not our India, we are not having any standard things, and we are following the European standards. Europeans only decides the throughout the world. European standards only followed by the many of the countries, because that's why we call it as Euro norms. And basically, then we have changed the name, as European standards, we have a Bharat stage one, stage two, stage three, and at present we are using the stage four phenomena. And basically, what European countries will follow the norms, very standard norms. That again we are converted into Bharat stage one, Bharat stage two, and BS emissions. We are putting a lot of names to the standard, but basically the standards will be taken from the European standards only. And particularly in these pollution norms, we call it as Bharat stage or the BS norms. Emission standards are government instituted emission standards that all motor vehicles have the comply with if they are to be sold and driven in India. Basically, India will have the, now presently India will be following the stage 3 and stage 4 norms. Whatever the vehicle is coming out for the registration, all vehicles should follow the requirements of Euro 4 norms. And those modifications only all vehicles has made up heavy rates and all. Previously, the Maruti is a very economical vehicle and Indica is a very economical vehicle, but they changed the mode of design and all, and the rates will be increasing and it will meeting of the Euro 4 norms. And that's why they are all small vehicles will be given to only petrol mode and gasoline mode only, SI engines only. There is no CI engines are coming up from, but those diesel engines will not meet in the Euro 4 norms, Euro 4 standards. That's why they have made a lot of modifications in the engine design, and the ECU will be using electronic control unit. We already discussed it. This electronic control unit will reduces the sending of the rich mixture inside the engine. Once the rich mixture will goes, a lot of hydrocarbons and carbon monoxide will have. The BS norms are based on the European emission standards. That's just I am telling you. The BS norms or bar stage norms will be European standards only, and were first set into 2000 year, equivalent to the Euro 1. The first iteration was known as the as India 2000. We made the small name change, that India 2000, and the norms will be BS1, Bharat Stage 1, and subsequently the emission standards were called by BS2 and BS3 and BS4. These are the different standard emissions we'll be following for India. Presently, we are following BS4 norms for all new vehicles. And old vehicles, those who are having and the life of 15 years or more than 15 years, they're all having a for stage 1, stage 2, and stage 3 vehicles. And whenever you are purchasing the vehicles, the old one, you should see that, and present norms is the Euro 4 norms. But if you want to buy any vehicle, you have to go for a new vehicle only, but to meeting of the standard norms of BS4. With the implementation of the new norms, pollution levels are expected to reduce to a large extent as a particulate matter, PM. And particulate matter is very dangerous. Basically, it will come through these diesel engines, and where we are going to have to stand it outside. And this particulate matter will goes inside and gives a lot of diseases to human health hazards. The concentration should be decreases. About one third of the air pollution is caused by the motor vehicles and cars. Previously, the pollution will be coming from industries only. Now, presently, we have a lot of vehicles. Even Corona time also, many people are traveling their own vehicles because of the they cannot move it in the public places, and they cannot mix up with the public and all. Public transportation, most of the people are avoiding, and they are buying a new vehicle, small or big vehicles, and a lot of motor vehicles are coming out, and a lot of motor vehicles are giving the pollution. Particularly in Delhi, you are seeing it. Bombay, you are seeing it. Chennai, you are seeing it. Even Hyderabad also comes under these ranges, the pollution levels. And the pollution levels will be decided by, we have a pollution controlling unit will be there in Telangana state, and they only decides these pollution levels of the state and pollution level of automobiles and all. Particularly Euro 4 norms are the very standard. Everybody should follow the Euro 4 norms for making a use of your vehicle, and cleaning of the carburetor, cleaning of the engines, and cleaning of the spark plug. A lot of things can make you change of reducing of the emissions. The volume of particular matter, 2.5, is between 20 to 40 micrograms per cubic meter. In cubic meter, you are going to have a 40 micrograms of the particles will be there available in BS4 fuel, where in BS4 it was up to 120 micrograms per cubic meter. But also will be having and lot of things, modifications of a lot of the excise. They made it to 120 micrograms per cubic meter. The sulfur content in BS4 complaint, fuel is brought down and 5 times when compared to the BS4 version. It is 10 ppm of sulfur as against the previous 50 ppm will be there in the previous stages, and the Bharat stage 4 will given to 10 ppm of the sulfur. And sulfur is the fuel contributes to fine particles matter emissions. High sulfur content in the fuel also leads to erosion and wear of the automobile engine. Under this BS4 fuel, for 1 kilometer, a car will emit 80% less PM and almost 70% less nitrogen oxide in diesel engines. The petrol engine, the emission of nitrogen oxide would be less by 25%. Because BS4 will use the lot of emission controls particularly, and the combustion phenomena also will be having the modification to give the less emissions. BS4 norms will lead to reduction of the emission of certain hydrocarbons that are produced because of the incomplete combustion of the fuel. Because we know that, and previous classes we have discussed it about the SI engine combustion and CI engine combustion, how the percentage will be increasing. If you use the superchargers and turbochargers, the percent of combustion rate will be increasing. And if you have a good oxygen percentage in the air, and also you are going to get the good combustion. And BS4 fuel contains lesser air pollutants compared to the BS4 fuel. BS fuel contains BS6 fuel, and will use the BS4 fuel also. The levels of poisonous, highly reactive gases that form when fuel is burned at high temperature, such as NOx and oxides of nitrogen, are expected to reduce. India 2000 year we have Euro 1 norms, and BS4 has Euro 2 norms, BS3 will be Euro 3 norms, and BS4 is Euro 4 norms. Now slowly we are moving to the Euro 5 norms and Euro 6 norms. Already in all foreign countries, they are following the Euro 6 or Euro 7 norms. When I visited to do my postdoc fellowship in 2007 itself, they are following the Euro 4 norms. At presently, we are after 15 years or 16 years, we are following the Euro 4 norms. And basically in petrol distilled vehicles, nitrogen oxide NOx limit is 60 mg and BS4 is 80 mg and particulate matter PM limit is 0.5 mg kilometer per kilometer. And here if you go to BS4 version, we're going to have complete zero. Particulate matter also very dangerous for this. If you go to the diesel vehicles, nitrogen oxide NOx limit is 80 mg in BS6 and 250 mg in BS4. And we have particulate matter ppm limit is 4.5 mg in kilometer and 35 mg in kilometer. And we have 45 mg in kilometer and 25 mg in kilometer. And the CNOx emissions will be depends upon the this thing combustion rating 170 mg per kilometer and 300 mg per km. And this is about Euro 4 norms, and you have the EGR method. Okay. Hello, friends. Any doubts or clarifications regarding this? Hello?
No, sir.
Hello? Hello?
No, sir.
Sir. Hello? Any doubts?
No, sir.
No, sir.
Okay. Then we will end up. And tomorrow I will take 10 to 11. Krishna will take 8:30 to 9:30. Hello?
Yes, sir. Yes, sir. Okay, sir.
Okay. Our exam will be on 16th evening 4:30. Okay. Everybody is okay?
Sir.
Okay.